So to determine if this function is continuous, we basically have to graph the three parts and then see if they match up. So if they were to look something like, okay, we graph one part, it ends right there, and then another part goes like that, that's not continuous. So do these parts match up continuously? So to begin with, the x values that are important are 1 and 3. And then this one is a line that has a slope of 1 and it crosses the y-axis at 1. And we're supposed to use that to the left of the number 1. So if we were to substitute a 1 in here, we would get 1 plus 1 is 2. So it's a line that's going to end right here. And I use a closed-in circle because this has an equals right here. It goes through the y-axis right there at 1. So it would look like this. Next up, this 1 over x. So I use that in this middle part between 1 and 3. The first one would be 1 over 1, so that's at a height of 1, and use an open circle since this doesn't have equals. And then next, if you have a 3 in there, we'll go down to 1/3. And it's actually going to look like a little branch of a hyperbola, a little piece of a hyperbola, so it's got some curve to it. And next, this is the square root function, but it's been shifted over to the right by 3. Or in other words, if you substitute a 3 in there, you get the square root of 0, which is 0. So that's starting at a height of 0, and then the square root function just gradually goes up and up like that. And so this function is very not continuous. It's got two major gaps.